I'm Ahmed Daud, and in this session, we will explore cross validation. Okay, in the last sessions, we have seen what are the hyperparameters of the decision tree and what are the underlying concepts of these hyperparameters. We have explored very well, and we also have discussed some of the attributes and methods mentioned in the sklearn documentation. So now, actually, the this session should be the part of Grid Search CV, so that we can do some pre-pruning and we can do some coding part. But before that, to go towards the actual lecture, I want to elaborate here cross validation, because multiple time you have seen that we are mentioning CV is equal to 5 or something in a lot of cases, like in Grid Search CV, we also have mentioned multiple times CV is equal to 5. So what actually the cross validation and what is the intuition behind that? Okay, so here you can see that image, and in this image you have here let's say training data points, and there are 100 training data points, and you have splitted these data points into five parts, and then you are training your data point model, your actual model, whatever model you are using on this training part, and one part you are considering as to evaluate the model. Okay, then you here selected a second part as a for the testing part, and other four parts you have selected as a training part. In this way you perform five iterations, and each time your testing data points are different compared to before. Okay, so after the five, if you have mentioned here CV is equal to 5, so after five iterations you have evaluate your model on five different testing data points, and you have trained your model each time on different training data points also. Okay, um, relatively different training data points, because in this case and in this case this amount of data points are the same for the training purpose, but here at this point at this point here in this case there is a training data point, but this training part is considered here as a testing data points. Okay, so in this way cross validation actually performs, and I know you are already familiar with that. After the five iteration and whatever you have mentioned here, then you will have multiple like five scores against each model, and then you take an average and you consider average score. Okay, so I hope you are already familiar with that. The main part that I want to elaborate here, why we go towards, or why we went towards the cross validation, what was the reason behind it. Okay, some of you maybe were having the question like if we split our data point like we usually do into training part and testing part, and training part we can use to train the model, and testing part we can use to evaluate the model, why uh, we do cross validation. So the reason we will discuss here one by one. Okay, let's say you have a training data points, the whole data points that you have available, and you have separated your data points into training part and testing part. Okay, and now here your aim is a hyperparameter tuning or model selection, or whatever your aim is. You are going to train 100 different models with different hyperparameter values. For example, here your aim is to select a model with best fit parameter values, or you can say best hyperparameter values. Okay, so here you are training 100 different models, 100 models with different hyperparameter values. Okay, and then you are evaluating all the models on the test data set, and let's say you have selected that model number 3 is giving you the best score out of all the models. Okay, like it is giving just 5% error, or you can say 95% accuracy this model is giving on the test data set. Now, what is the drawback in it? Let's say when you will launch that model in the production, maybe you will see more than the 5% error. Let's say you will see 15% error. Okay, so what was the reason that although you have evaluate your model on the test data point, which was quite new for the model, because model was not trained on these data points, But in the production, again, when our model has seen a new data points, it is not performing quite well as we have test during our testing data points as it performed there. Okay, so what was the reason here? The reason is that it is our model that we have selected here. It is performing quite well on these testing data points. Okay, unfortunately, we have adapted a model that is performing well on these number of points, and it is not the case that this model is giving a good results on the new coming data points. It is the case, it becomes the case that it is performing well on these number of points that we are using. Okay, because we are evaluating all the models on these test data points, and maybe there will be some model which perform quite well, but there is another model which perform quite well on these test data points compared to all other models, but it is actually not much good. So that can be the reason that your model is not working good in the production. Okay, so here I have also mentioned the problem is that you made the generalization error multiple times on the test set, and you adapted the model and hyperparameters to produce the best model for that particular set. This means that model is unlikely to perform as well on new data because you have adapted the model which is working well on these number of data points. Okay, on these number of data points. Now, second option you can say, if you split your data points into training and testing part, and again in the testing data points, you will split into two parts: train data set and validation data set. Okay, a lot of time people are using that technique also. What in that case you will do? You will train your all the models like 100 models with different hyperparameters on this training data points, and then you evaluate your model on this validation set, and you selected some model that is performing well on this validation set. Let's say model number 42, and now a final launch or a final you can say launch of that model in the production. You again evaluating this model to before launching, you are training this model on the whole training data points, and then you are again evaluating your selected model that you have selected on the validation set to evaluate the model before the actual production. Okay, so what is the reason is that here the same type of the cause that were occurring in the same type of problem that were in the option number one. It is again maybe a chance that you will get some model that is performing well on validation set, but it is actually not much good. Okay, and if your validation set, you will increase your validation set to that point, let's say to that particular point, and you decrease your training data points, and then you are evaluating your model, but it is not a good practice that you train your model on a small number of data points and you are evaluating on a large number of data points. And it will be like that if your model is working, it means that you are training your data points which is quite less than on the training data set, which is quite less than to the actual training data set. Okay, maybe here you will add again, will get some suboptimal model which is not much good model, but on the basis of these small amount of training data points, some model can good can perform well compared to others, but it is again not a good choice. And there I have also mentioned you can say this one like it will be like selecting the fastest sprinter to participate in a marathon. Okay, you have selected a model that you have trained on a very small data points. If you have increased your validation set, okay, and now you are going to train that particular model that you have previously trained on a small data training data points. Now you are going to train that model or model with these hyperparameter values on a large training data set. Okay, so it will be not a good practice again. Okay, And if you will keep the validation set small, then again the problem like we were facing in the option number one. Now there is option number three, and this option number three is quite perform well. You split your training data points into multiple parts, and then you use each time different training data points and particularly different test data point, and then at the end you calculate the average score. So this work quite well, but there is a problem which is really the case that we face, but in the production or in some high level models maybe we face some time issues or time complexity, because training time will be multiplied by the number of validation sets. Okay, so that can be a drawback of that model, or that you can say approach option number three. But this approach is quite well compared to the other approaches. Okay, so option number two is quite similar to the option number one when we have less number of data points in a validation set. If we increase validation set, then training data points will decrease, and it is also not a good choice to train a model on small number of data points, because it cannot able to get the fully patterns from the training data points. Okay, because always we are learning from the our you can say training data points, irrespective of the model. Like a parametric model also have to learn some parameter values from the training data points, and non-parametric model totally depends upon the training data points. So this is all about the cross validation. That's why we use that type of approach. And in the next session, we will have a look on the grid searches part, and we will try to perform pre-pruning. So far now.